So the article I chose to review is the Tendril of the Hop and Tendril of the Vine, Peter Guthrie Tite and the Promotion of Quaternions, Part 1. Uh, Quaternions are mathematical objects whose birth is intertwined with the birth of vectors. And vectors abstract away the dependency of the chosen coordinate system for Cartesian triples, and Descartes' Cartesian triples will be covered in Pamela Webster's math history course. Some incidental properties of quaternions is that they're non-commuting. This aspect was particularly shocking to the mathematical community because that commutativity has been taken for granted for so long. And the inspiration that I, J, and K were non-commutative struck Hamilton so powerfully that he scrawled them on a bridge over the River Liffey. Interestingly, I, J, and K were conceived of as vectors whose magnitude was square root of negative 1 rather than as numbers whose square was negative 1, as I had always assumed. Some problems with quaternions is that when they were conceived, of course, there was no novice text introducing people to them and their use, and there was no demonstration of their special fitness to physical problems, and they lacked a figurehead support. The leading candidate for which would have been William Thomson, Britain's leading scientist of the day. However, he was pig-headedly against quaternions and vectors, saying quaternions came from Hamilton after his really good work has been done, and though beautifully ingenious, have been an unmixed evil to those who have touched them in any way, including Maxwell. He also said that vectors are a useless survival or offshoot from quaternions that has never been of the slightest use to any creature. So the conceiver of quaternions was William Rowan Hamilton, and he sought to transform one vector into another via a scaling rotation operation. Though those seem very physical operations to me, the article says that he lacked physical inspiration for his ideas, and he wrote them up in a book called Lectures on Quaternions. But the chapter on the differential operations in particular faltered at attempts to apply them to solve physical problems, and this caused Peter Tite, who had been reading along the book after its publication, to shelve the book for many years. He only returned to it after he read one of Helmholtz's papers on vortex motion that implied that the quaternions might be useful in the theory of potentials. Tite demonstrated an unusual familiarity with quaternions, but needed discipleship. Fortunately, he was introduced to Hamilton through a mutual friend, and the two of them built a solid mutual support when they letter-writing correspondence. Through that correspondence, Tite gained much mastery over quaternions, to the extent that he and Hamilton wanted to address the lack of a novice text problem with quaternions, but Tite felt the need to seek permission from Hamilton before he could write his book, since he had gotten so much help through the letter-writing correspondence. They agreed to both write a book, and Hamilton would have the right to first publish, and he would concentrate on the underlying principles, while Tite would look at the physical applications and also some theorems and geometrical ideas via quaternion integration. This mutual support between Hamilton and Tite chilled after Hamilton received advanced publicity of Tite's book, presumably fearing that Tite would ignore their deal to give Hamilton first publishing, and their relationship was only repaired after a summer visit from Tite at the observatory that Hamilton was ostensibly working at. In Tite's book, Tite also collaborated with Thomson on a treatise on natural philosophy, but putting up with Thomson's stance against quaternions stifled much of Tite's own work with quaternions, and Thomson managed to force the omission of quaternions in the first edition, but it was included in the second, fortunately. Tite and Maxwell had a lifelong friendship from Edinburgh Academy, and that friendship inspired Maxwell to write in his book Quaternions, but he only used the vector part of them, not the scalar part, and he only used them to summarize some of the results rather than use them in the development. He didn't think the public nor he himself was ripe for quaternions. He was very interested in the proper communication and would like to bring out the length through common mathematical representation. I enjoyed hearing how the operators got their names through Maxwell's work with quaternions.